Good morning. Myself Sadish Saran, working as an assistant professor, Department of Medical Electronics, SRM Valliyamai Engineering College. I am going to handle the subject PMD 604, Advancement in Diagnostic and Therapeutic Equipment. In that unit number, Cardiac Equipment. My first topic, Electrocardiogram. It is used to record the electrical activities of brain. The device capable of recording and printing the ECG on paper is called electrocardiogram. Einstein was the inventor of the first device capable of printing the ECG on paper. Heart is divided into four chambers. Four chambers are left atrium, right atrium, left ventricle, right ventricle. It is located between, there are four valves. One valve between right atrium and right ventricle, another valve between left atrium and left ventricle, another valve between right ventricle and the lungs, then another valve between left ventricles and aorta. These are the four valves present here. The first valve, right atrioventricular valve. This is known as a tricuspid valve, otherwise called as the right atrioventricular valve. It is located between right atrium and right ventricles. It prevents the backward blood flow from right ventricle to right atrium, right atrium to right ventricle. The next valve can be called as a bicuspid valve, otherwise called as a left atrioventricular valve. It is located between left atrium and left ventricles. It prevents the backward flow of blood from left ventricle to left atrium. Then another valve called as a pulmonary valve. It is located between right ventricle. It has three half moon shaped cusp. It does not allow blood to back to the right ventricle. Then another valve called as aortic valve. It is located between left ventricle and aorta. It does not allow the blood to come back to left ventricle. Heart consists of three layers, namely pericardium, endocardium, myocardium. Pericardium is the outer layer of the heart. It keeps the outer surface and prevents the heart from the friction. Endocardium, it's the inner layer of the heart. It provides a smooth path for blood flow. Then myocardium, it's the middle layer of the heart. It acts as the main muscle of the heart. It is made up of short cylindrical fiber. Then coming to the blood vessels, there are three main types of blood vessels. Atrium, artery, vein. These are the two different types of blood vessels. Artery, vein. All artery carry pure blood except pulmonary artery. Similarly, all veins carries impure blood except pulmonary vein. Arteries are thick-walled vessels used to carry the oxygenated blood away from the heart. Blood vessels that carry pure blood from the heart to various organs. Veins, they are thin-walled vessels through which impure blood returns to the heart. Then another vessels called as the capillaries. These are the small blood vessels. Nearly 8 lakh kilometer capillaries are present in the human being. The heart pumps the blood by a movement termed as a heartbeat. The normal heart rate is 72 beats per minute. The heart pumps the blood through pulmonary circulation to the lungs and through systemic circulation to the other organs of the body. Then ECG waveform. It consists of P, QRS, T and U wave. P, it is due to depolarization of atria. QRS due to depolarization of ventricles and repolarization of atria, and T wave, it is due to repolarization of ventricles. ECG waveform. The description of the 5 ECG waveforms is as follows. P wave represent the depolarization impulse across the atria. QRS, all the three wave represent the ventricular depolarization. T wave represent the repolarization of ventricles. These are the ECG waveform. P wave is due to depolarization of atria. The amplitude is 0.25 millivolt and the duration of 0.12 to 0.22. This is known as a P wave. Then R wave in the QRS complex. It is due to repolarization of atria and depolarization of the ventricle. The amplitude of R wave 1.6 millivolt and the duration of 0.1 to 0.7 to 0.1 second. Then T wave, it is due to repolarization of ventricle. The amplitude of T wave 0.1 to 0.5 and the duration of 0.05 to 0.15 seconds. Then U wave, slow repolarization of atria, ventricular Purkinje fiber system less than 0.1 and 0.2 second duration. Then ECG lead system, it is totally 12 lead system. Bipolar limb lead system divided into 3. Then unipolar limb lead system, it is 3. Then another one, unipolar chest lead system, 6. This is Einthoven triangle. Einthoven inverted the triangle starting from right arm, TO2 left arm, to left leg, and again back to right arm, forms a triangle known as a Einthoven triangle. It is used to describe the bipolar limb lead system. That is a These are the recommended position of electrodes: left arm, left leg, right arm, right leg. Left arm, it is a black color lead. Right arm, it is used to describe white color lead, and right leg, green color lead. Then left leg, red color leads. These are the recommended position of electrodes for picking the ECG. Then this is a bipolar limb lead, as already described. The Einthoven described the it is used to for a bipolar limb lead system. This first one, bipolar limb lead, lead one. It is between right arm and left arm. So one end of the left arm is connected to one end of the operation amplifier. Another right arm is connected to another end of operation amplifier. Provided RL is used as a reference. This is a lead one system. Similarly, lead two, it is between right arm and left leg. So one end of the operational amplifier, there is a non-inverting, it is connected to left leg, and inverting terminal of the operational amplifier is connected to right arm and provided RL as a reference. This is known as the lead 2 system. Then this is a lead 3 system. It is between left arm and left leg. So non-inverting terminal of the operational amplifier is connected to left leg, and inverting terminal of the operational amplifier is connected to left arm, provided RL is used as a reference. This is a lead 3 system. Then another 3 augmented unipolar limb lead system. So that is a right arm, AVR, AVL, AVF. These are the 3 augmented unipolar limb lead system. First, AVR, right arm, it is connected to non-inverting mode of operation amplifier. The remaining 2, there is left arm and left leg is taken out by means of a resistor and common pointer which is connected to inverting terminal of operation amplifier, provided RL is used as a reference. This can be called as a augmented voltage right arm. Then next one, augmented voltage left arm. Left arm is connected to non-inverting terminal of operation amplifier. The remaining 2, the right arm and left leg is taken out by means of resistor and common pointer which is connected to inverting terminal of the operation amplifier, provided RL is used as a reference. This is a AVL, augmented voltage left arm. Then augmented voltage foot, even though we are having 2 legs, one leg is used as a reference. So this left leg is considered as a foot. So the left leg is connected to non-inverting terminal of operational amplifier. The remaining 2 point, that is right arm and the left arm, is taken out by means of resistor and common pointer which is connected to negative terminal of operational amplifier. This is a AVF, augmented voltage foot. This is another 3. It can be called as unipolar limb lead system. First 3, lead 1, lead 2, lead 3 is a bipolar limb lead system. The next, unipolar chest lead. These are the 6 various positions. That is V1, fourth intercostal space of a right sternal margin. V2, this V2 is the fourth intercostal space at left sternal margin. This V3, it is midway between V2 and V4. V4, fifth intercostal space at mid clavicular line. V5, same as V4 on anterior axillary line. V6, same level as V4 on mid axillary line. These are the another 6 unipolar chest lead. So totally bipolar limb lead 3, unipolar limb leads 3, unipolar chest lead 6. Similarly here, this is chest electrode is taken to non-inverting terminal of operation amplifier. The remaining 3 points, the left arm, left leg and right arm is taken out by means of resistor and common pointer which is connected to inverting terminal of the operation amplifier, provided right leg is used as a reference. This is a unipolar chest lead. So totally we are having 12 lead system. 3 bipolar limb lead system, that is lead 1, lead 2, lead 3, and another 3 unipolar limb lead system, AVR, AVL, AVF. Then last 6 unipolar chest lead. So totally 12 lead system in ECG. These are the ECG recording setup. Electrodes from right arm, left leg, chest lead. It is given to defibrillator protection circuit. The electrode used for taking ECG measurements are connected in right arm, left arm and chest and left leg of the patient. The other end of the electrodes are connected to lead selection logic through defibrillator protection circuit. The protection circuit employ buffer amplifier and over voltage protection circuit. Four buffer amplifiers are utilized here. One buffer amplifier for each electrode. Over voltage protection circuit is used to protect pre-amplifier and power amplifier from over voltage. Next one, lead selection logic. By using this block, we can choose either bipolar limb lead type or augmented unipolar limb lead type. The next one here, calibration circuit. If lead selection is changed, then some artifact is introduced in the output of the ECG. So calibration circuit is used to help the technician to calibrate the output unit. When the lead selection is changed, then the amplifier is switched off for some time. After passage of artifact, some noise, the pre-amplifier is again switched on. Then coming to pre-amplifier, here the differential amplifier with high gain and high CMRR is used as a pre-amplifier. The next one is a power amplifier. The power amplifier is used to drive the output unit. The pin motor is used in the output unit. This pin motor needs sufficient electrical power to initiate the recording. So power amplifier with high power gain is used here. The next one, the circuit shows power amplifier in the ECG recorder. The feedback network consists of some RC circuit. It provides necessary damping to the pin motor unit. Then coming here, auxiliary amplifier. It is connected between the lead selection logic and right leg of the patient. The impedance of all electrodes are not equal. The differential amplifier used in the pre-amplifier block is not sufficient to completely eliminate the common mode signal. So auxiliary amplifier is used to reduce the common mode signal. The output of the auxiliary amplifier is connected with right leg. So the output drives the body to zero common voltage. So noise is reduced. Hence CMRR is also increased. Then output display unit, here CRO or paper chart recorder is used as a output unit. Generally paper chart recorder is used, pen motor is used in the output and pen motor is used in this recorder. The paper speed is 25 mm per second in US manufacturing system. The paper speed equal to 50 mm per second in European ECG nations. Then analysis of ECG waveform. This is a normal ECG waveform. This shows the normal ECG waveform. Then this is a second one. Here PQ segment has a prolonged condition greater than 0.22 second. So this figure shows the first degree AV block. So first degree AV block. Here PQ has a prolonged conduction period of greater than 0.22 second. Then the next waveform, QRS complex is widened. So QRS is greater than 0.1 second. So it's a widening of QRS complex. QRS, when QRS period is greater than 0.1 second, this is a result in bundle block. Then another one here, ST segment is elevated. This can be called as a myocardial infraction. This there is no that ST in the PQRS, that is ECG signal is elevated. This results in myocardial infarction. Then ST segment is depressed and negative wave is present. It is a T wave. When T wave is negative, it results as coronary insufficiency. So the negative T wave, normally it is positive, it results as coronary insufficiency. Then it's a triangular waveform. Here there is a train of pulses instead of PQRST wave. This results as ventricular fibrillation. It may lead to death. It should be immediately cured by defibrillator. Okay, thank you.